Okay, in this lecture, we will graph this equation and identify the domain and the range. From here, we probably have no idea how does the graph look like. So we want to see if we can change this one to the standard form. Okay. Now, both sides, before we do that, we know radical something is always positive. Then we know y over 4 is actually positive. And then, both sides, if you want, multiplied by 4. 4 cancel each other. 0 times 4 is 0. So y is greater than 0. So the range of y is 0 to infinity, including 0. So basically, this picture is above x-axis, since all the value y is positive. Okay. Now, secondly, we know inside the radical sign, the expression is 1 minus x squared over 25. This one has to be greater than or equal to 0. Okay. And then if both sides added by x squared over 25, add, then you may cancel these two quantities. Left-hand side is just 1. Right-hand side is 0 plus x squared over 25. And then you may then do 25 times two sides. You'll have a 25 on the left. 25 times 1 is 25. Right-hand side, they cancel each other. So it's x squared less than or equal to 25. Okay? Now, choose the square root on both sides. What we get will be 25 square root, which is 5. On the right-hand side, you just put absolute value there. Absolute value is between 5. Absolute value is less than 5. Then x must be in between negative 5 and 5. Okay? If you put negative 6 there, you choose the absolute value is going to be greater than 5. So it has to be greater than negative 5 and less than 5. Okay? Now, we know the domain is negative 5 to 5. Okay? So basically, this one defines a function. It is a function of x. Y is a function of x. Yeah. And the domain is negative 5 to 5. Range is positive, including 0. Now, we got to graph this one is we want to change this one to the standard form. Both sides, we choose square. That's the one right here. Y over 4 squared equals 1 plus x squared over 25. Okay, so what we get is y squared over 4 squared equals 1 minus x squared over 25. If both sides you add x squared over 25, then you see that you may cancel this. Have a 1 stands alone on the right. Left-hand side, you have x squared over 25 plus y squared over 4 squared equals 1. Or you may write x squared over 5 squared plus y squared over 4 squared equals 1. Which one is bigger? Which one is A? So, A is down below x-axis. That's a major one, major axis. So A is 5 on x, and y is minor x-axis is 4. Here is only half of the ellipse is because of what? Y is above x-axis, cannot be negative. Okay, so this is roughly the picture. Yeah, and here, you know, if you draw a vertical line, it has at most one point with curve. So what? So here you may claim that y is a function of x. Okay. All right. Now let's look at the second example. This is the second example. Find the eccentricity of the ellipse. We want to identify what? A and B. A, which one is bigger, which one is A? You first change this one to what? To the standard form. Okay. You may not in this case. You see which one is bigger, which one is A. So you have A squared is 25, B squared is 9. And then you can find out C by this identity. That's 25 minus 9 squared, which is 16. Then C comes to be 4. The eccentricity is defined as the ratio of C over A, C to A. So C is 4 and A is 5. You see, A squared is 25, so A is 5. Then we have found eccentricity is 4 over 5. That sounds like an easy one, huh? Now, here is the third example. The third example is that comet C has an elliptical orbit of eccentricity 0.9453 with the sum at 1 focus. Okay. Yeah. And we were also told the greatest distance between the sun and the comet is 2703 millimile. Millimiles. So you may want to write S here. And then we want to find the least distance between them. We know right down here is an elliptical orbit, and it's an elliptical orbit. Okay, and the eccentricity is the one right here. So C over A we know is this ratio in this case. So basically we know down here C over A is given 0.9453, and you know both sides you can multiply it by A in this case. Cancel the A here, you have a C stands alone, and A is 0.9453A. C is 0.9453A. That's one thing you can find. Another thing is that if you look at this picture, this is the comet. C is right here. Comet, this point is right here. Sun is right here. Okay, and then the elliptical orbit is in this way. Okay, and you see comet, I should put what? Comet right here. Okay, that's the distance. Longer distance is actually A plus C. Okay, A plus C. This one I may do it. Sum is here. Okay, and then commit. Okay, so you see it rotates around the sum. Okay, yeah, all right. Now down here is that the big distance is actually A plus C. We know this is the center origin. This is the major axis. So A plus C is 2703 millimoles. Okay. Now we have two equations. We can solve for A and C here. You see A plus C is 2703, and then you can do is you put this C into here. Okay. Then you have A plus C. This is our C, 0.9453A equals 2703 millimoles. And then you can find out A. You see there is a 1 down in front of A. So 1.9453A equals 2703. Then you have A is 2703 divided by 1.9453. Okay, so A comes out. If you have A, you put it back. Here you have a C. Okay, so C comes out in this way. This is 0.9453, and then this is C. C. Plug in there. That's 2703 over 1.9453. Okay, so you have A and C already. Now what is the shortest distance? You know, this was A, this was also A because they are symmetric. Comet was here, but it rotates. Okay. It rotates. Then it will be here. And then shortest distance will be A minus C. A longer one minus the shorter one. Okay. Then you see the least distance is A minus C. A is the number here, 2703 divided by 1.9453, and C is right here. Okay, yeah, that's value here. And then you then have what? Approximately 76 point, many digits down here. It's not miles. Then you know the comet is going to be burned out. Is what? Millimoles. Okay. Yeah. And here I made a change is that with the sun at one focus. So sun is here. The comet is there. Okay. All right. Yeah. So please review this lecture. I'll see you next time.